welcome to the first episode of a series of me just implementing stuff in C++ to get a bit better. Today we're doing the unique pointer, which apparently is a more common interview question these days. But to start with, I'm actually just going to jump through the tests that I have. So I'm just using the Google test suite here. The whole point of a unique pointer is to manage a raw pointer. So the first test here kind of deals with construction. So the idea is you call in a new integer on the heap, and you make that a pointer. That again then gets passed into the unique pointer. In this case, it's an int, but it's actually supposed to be templated. Then we have the not equal. So we're going to use the get operation, and it shouldn't equal the null pointer. And then once we do the equal operation, it should equal to 42. And that's when it's with the dereference operator. Then we have this thing called the tracker, which is just like a little struct over here, which increments up and down depending on how many copies of it are alive. It starts off at 0, so the idea is, we have a tracker. It'll be 1 once it's created on the heap, and then the unique pointer should be able to get access to that, and it should equal 1. And then once the unique pointer goes out of scope, the tracker decrements, and then it goes to 0, and that's what that second test is here. In the unique pointer, move is allowed, so this is just checking the move operation with std move. I actually don't use std move a lot, but yeah, that's the idea. Is like, you have a int of 10, you use std move, so now that b unique pointer should equal that, which is what this check is here. Move assignment as well. And then the famous self move does not break. So the idea is that I got to write the code so that it does a little self check before it does the equal operation. Yeah, that's one of those weird double delete cases that I don't know too much about, but apparently it's something I got to watch out for. Then there's a few API calls. So there's a release, dot release if you've used it, dot reset, and then just to check that dot reset has a new object. So I'll just hop into my main function here. So because it's a template class, I'm doing the only header, so .hpp. So in that header file, we have our class, and I just left a few comments here to kind of remind me what to do. And then up here, there's just some instructions, I guess, in general. So after we do the disallow copy and all the API calls, I'll just maybe in the next video I'll do the scope timer and the file wrapper, all this other stuff that ChatGPT recommended I try out. So all right, I'll get into it. So like I said earlier, this one is going to be a template class, so I'll just do type name T. All right, and then in our private access modifier, I guess, the most important thing that the unique pointer is actually managing is the raw pointer underneath. So yeah, just a pointer of type T, and then M pointer, which will just be empty for now. I'll just get going on the constructor here. So my unique pointer, I realized a lot of people from other videos I've seen and other code I've seen, it's just like you kind of overload this operator to have it take a pointer or just to be blank, and then it does a null pointer. But the smarter way is just to do the default argument. So yeah, just set it to be null pointer unless otherwise specified, and that's where I'm going to come in, and I'm going to just assign that private member variable to be whatever you pass in. That should work. All right, and then the destructor. So this is where we get into the rule of 3 / rule of 5. So whenever you have a user-defined destructor, right, it kind of shows that you're managing the memory on the heap. So that therefore you should be able to define you should expect to need user-defined behavior for the copy assignment, and then rule of 5 is like move and then move assignment. So I'll just do that here. So delete raw pointer. I think that's good. What I want to do next is actually get into the API calls. So the first function is get. Before I write the argument, I'm just going to do that. So get, it will be a constant operation, and all we're going to do is just return the pointer that we're managing in this class. So I'm just doing that. And because we're returning the raw pointer, right, the type that we return is just going to be a T star. So the next one is going to be the the dereference operator, right? So you're dereferencing a pointer, so therefore you should be able to pass or return a reference. So I'll just go, this is where I always get confused. So operator, I think it's like this. Looks like functions. Let's try that again. All right, delete operator star and then close brackets. I think that's right. All right, again, this is going to be const, so I'm going to return the dereferenced pointer. Beautiful. I think that's, I'm hoping this is right. The problem is if I run the test case, it'll probably just break because all the tests that I need that matter are kind of at the start. All right, so let's just do the arrow operator. So this is interesting. When you get the arrow operator right, you're kind of you're doing a dereference on the pointer, or that's one way to think about it. But it turns out that we have to watch out for operator chaining. So instead of returning a reference, you're actually returning a pointer again. So operator. Okay, just like before, I think. And then this one is also const, right? We're not going to be changing what we're accessing. And we're just returning the raw pointer. Okay. Okay, so we have release. So release basically coughs up the pointer that you're managing, right? The raw pointer that you're managing, and then we'll kind of reset m pointer to be null. So I'm just going to do auto temp m underscore pointer, right? And then m underscore pointer equals null pointer, and then I'm going to return temp. Okay. All right, and then reset. So reset is very similar, except this time we're gonna take an argument instead of just doing the raw release. So the way to do it is to do void, because we're not actually returning anything this time, and then we're gonna take in a t star other. Similar to before, I'm gonna do a default argument like that. All right, now we're going to delete. We're going to delete the pointer that we're actually managing first. Oops. And then we're going to set that member variable to be other. All right, so let me think about that for a sec. So taking in a t star and I set it to a t star, so it shouldn't t pointer. So it shouldn't need to be dereferenced. Okay. All right, so I have my APIs done. Now we're going to get into the copy constructor. Copy constructor, copy assignment, move constructor, and then move assignment. So copy is disallowed. The idea being that you want it to be unique, therefore you're not able to copy without specifically doing a move assignment. So the way that looks is we're going to take, when you do the copy, it looks like, is that right? Yeah, move copy looks like this. So yeah, const pointer. I think you're taking a reference. I'm just going to call it other. I'm going to say equal delete. So the fancy equal delete means it just disallows the operation. Similarly with the move, or sorry, copy assignment. That's where we're going to do the same thing, but it's going to be like a return value of a reference. And this time we're just going to overload the equal operator. I think that looks okay. So this time we're taking a const reference, right, and then delete. Okay, cool. I think that's good. We'll find out soon, I guess, and then I'll embarrassingly debug and look way dumber than I did at the start of this video. So similar to before, the move constructor is going to take a my unique pointer reference, but I don't think it makes sense to be const because you are literally stealing the things inside, therefore it's not const. But I'm going to call it other. And what happens? So I'm going to just so because it's a constructor, I don't need to worry about deleting the raw pointer, because this will be the first time it's ever used. So then I'm going to just go in here and just steal the end pointer. Oh, one thing I forgot is it's actually not like that. There we go. It's supposed to be a R value reference. So therefore, you can steal the R value. I think that's right. Yeah. Other.m pointer is equal to null pointer. There we go. All right. So we took an R value reference. We stole like the actual inner workings of it, the member, and then we're going to set that member to null pointer. Okay, and then my unique pointer, this time it's going to be returning a reference, and we're going to take the operator, the equal operator, and overload it with again an R value, call that other. Okay, and I left a little note to myself here. Don't forget to self-check. So the idea is you want to avoid deleting an empty pointer, right? So the first thing you need to do is check that check that in fact this is a different reference. So, oops, this is not equal to the other, right? So if I have an R value reference to the other, just do that check first, and then I'm going to go in, delete the pointer that I was managing. And then I'm going to set just like before, other.m underscore pointer. And then the other is just going to be null pointer. And then I guess I return this, but I got the function's expecting a reference. I got to dereference first, and then I guess if the behavior is if I am calling the same thing, I'm just going to return this. Okay. All right. I guess the easiest thing to do is just build. So I have my build set up here to be Google test, and I'm just going to run Control B, see how it does. Okay, I have a bug. Let's see. Delete 10. All right. 32. 132. Yeah, it does not look good. Okay. Let's run that again. All right, sweet. All right, it says all 8 tests are passed. I'm just going to expand this a bit and talk a bit. Oops. There we go. All right, so the first thing was the construction. It looks like it passed. Then destructor frees the memory. The move constructor transfers ownership. Move assignment transfers ownership. The self move does not break, because I guess maybe I can explain that again. Is the idea being that if you over here. So the idea is like the first step is to delete the raw pointer, right? So if it's like you're calling the thing itself, you delete the raw pointer and then you assign it to a deleted pointer, right? You get undefined behavior in this line. You're assigning it to something that doesn't exist. And then the other, which is the same thing, would then be assigned to null pointer. So I guess it doesn't matter in the way, but when you do this step, you do have undefined behavior. All right, self move does not break. Release works. Again, the release function is over here. Reset works with an argument, and then reset deletes the old object. So there we go. Anyway, more of these down the pipeline. Probably not educational to experienced developers, but it's more for my own accountability and keeping on top of it. In the next video of this series, I'm probably going to work on these guys, like implementing the timer, the file wrapper, and then the buffer class. I think I've already done kind of a rule of 5 thing here, but I'll probably do that again. And then I guess I'd make a log class to log the all of these calls. I probably could have done that in this video. But anyway, thanks for checking it out. Keep well.